Good morning, everyone. As we are gathering here today for just going through this conference, where we are presenting a proposal which is enhancing the, which is using the machine learning and towards the sustainability by using the electric vehicle to manage energy peak demand in UK. So once we're moving into this is our topic, as you can see very much clearly. The background is laying on these four areas. We are the peak energy demand, what are the peak energy demand challenges, and EV as energy storage substance, machine learning optimization, and the workshop focuses is the latter part. And the goal of this study is basically laying on these few areas and the other side as well. EV as a decentralized energy storage and machine learning optimizations, where the reducing the fossil fuel dependency, enhancing grid stability, and innovative EV income model. Because these all are coming from where currently the UK is experiencing on managing the demand, managing the peak demand by using the fossil fuels. Instead of that only, we are having a motivation of doing this, replacing the EV as a power source model, and even we are enhancing the grid stability by using those machine learning optimization model, and as well as a EV income model. And moving on to the other slide, that's also continuing the goals and the rationale of this study. Real-time data and predictive analysis. As we are using the machine learning, we are mostly using the real-time data, as we need the traffic as well as vehicle behavior data and also the predictive analytics, because of we are going to predict some innovation, the source that we can use for managing the peak demand, and scalable and sustainable framework, and also combining with the sustainable framework as I mentioned in the previous, bridging the technical and real world implementation also. That is why we are here, like we are presenting this proposal, because of the we want to make this elaboratively towards the researchers, policymakers, and the energy professionals, and finally the economic and most important economic and environmental benefit, because we are the ultimately the people are involving because of the environmental benefit as well as their financial or the economic benefit. Scope and information for these participants, and EV as a decentralized energy storage. As I said, EV will be a decentralized, not centralized, and machine learning and predictive analysis using the Bayesian probability model, and that is as the most initial part of the study. And innovative EV income model also we are going to present, or we are going to generate some kind of a innovative income model towards EV users. There will be a dynamic pricing as well as a contribution models, and the battery subsidies will be considered within this innovative income model. And continuing the scope and the information for participants, real world case studies and simulation are being considered under this one, because some of the countries like Denmark, Belgium already comes to a certain part of this EV bidirectional energy supply, and we as a team and we as a group, we are just trying to use that as a basic and continuing towards the future aspects, and addressing the key challenges like battery degradation. Once EV user is preferring to engage with this model, of course, battery depreciation is one aspect that they have to consider, and as from ourselves we have to consider. And user adoption, it's also under the user behavioral aspects, and grid integration barriers for sustainable energy management. Because, like once we come to the EV users, this comes as a new innovative source towards the grid, providing those sources, additional sources to manage the peak demand. Therefore, we should have some kind of upgraded facilities, such as grid enhancing, grid technology. Likewise, we moving on to the motivation as you can see, this red or this pink area, we call it as a peak energy demand within a particular day. There you can see that blue curve which is going up, and which you can see the peak of that. So there in here, the UK as a geographical area, we are considering mostly as a flexible source natural gas. We call it as NG. Natural gas is using to manage this emerging for the increasing peak demand. Therefore, the peak demand identification, we have clearly identified our motivation and the current dependency on fossil fuel, as I mentioned, the natural gas, impact on carbon emission. Of course, once you depending on most of the fossil fuels, CO2 emission will be more into the higher sides. That's why this is the ultimate motivation. Of course, this motivation is dragging to the Sustainable Development Goals, which has been agreed by the UK and the UNICEF, has been agreed in their agreements under the 7th goal, that is sustainable energy management, sustainable energy providing. So motivation continues, conflict with sustainable goals. Of course, as I mentioned, need for an alternative solution. That's why we are other than depending on the natural gases, the fossil fuels. Of course, the fossil fuels will be into the minimizing stage in the future. So we as a people, we as researchers, we as a people who are seeking for the new innovations, we should have the alternative solution, because of we have to have some kind of alternative solution instead of the sustainable fossil fuels. As the current issues with the peak demand in the UK, as I mentioned under the financial, I will go through with this. High energy cost, of course, because of the fossil fuel, and expensive grid management because of the new technology requirement with the high demand, with the increasing demand, and infrastructure investment needs, not only for the EVs implement, but also for some of the other aspects, because of the people needs are going high and they are demanding for the more energy demands. But still, when the renewable energies and the non-renewable energy sources are getting limited, we have to have some kind of infrastructure investment under these. And non-financial impacts, of course, grid stability issues and the energy security concerns. These all are coming under the. This is also combining with some of the major issues which are being merged with these current issues which are facing under the UK with the managing of the peak demand. Environmental impact is the most important, as we have already mentioned. The motivation is there. Increased carbon emission, that means we have already considered under Sustainable Development Goals number 1, affordable and clean energy. As a solution for that, we are going with this statement: slow renewable integration. Mostly the renewable integration in kind of seasonal variation and the geographical dependency. This renewable integration is much more considered when you come into the wind, solar and the hydropower. So that's how. And continuing with the current issues, the economic impact, fluctuating market prices. Of course, there are certain providers who are having different set of pricing levels, strain on public funds, because most of the projects are depending on the public funds. Therefore, people have to pay tax, and other than going for the welfare things, the government should go towards the public funds. Opportunity cost for cleaner alternatives. Sorry. Delayed transition to sustainable EV-based energy solution results in long-term financial and environmental losses, because these all the other issues are combining with this opportunity cost, because of people has to pay something instead of investing to those things. BESS as a benchmark, of course, BESS is kind of a thing which we can store the energy, store the excess energy which is generating from the solar as well as the wind or the hydropower. Battery energy storage system, we call it as BESS, and the excess energy utilization. Currently, peak demand management is utilizing that kind of a power management. Of course, this is also having the limitation, as I'm going to explain in the next slides. Support for electrification, enhancing the reliability of electric vehicle charging network, because most of them currently the electric vehicles demanding is based on the best solution. High initial investment, environmental impact, and a limited storage capacity, and the degradation of overtime lithium supply and resources countries. There are more financial and non-financial challenges which are using by the best, mostly the high initial investment and the lithium supply and resources concerned. These are pretty much against the concern for the environmental impact or environmental well-being, and also the limited storage capacity. Sorry. This has to be established on the some of the beyond areas, on the rural areas, other than the people. Disposal and recycling challenges. Under these challenges, most important thing is the disposal and recycling challenges, which is mainly combining with the dependency on renewable energy variabilities as well as energy losses. Of course, once you are transferring some of the energies from the faraway places to here, we might losses the things as heat, as voice, as well as some other obstacles. And the grid integration and the security and safety risk, most are combined in those. That's why we have already suggested some of the alternatives which have been like can be used with the data and data security, data safety, and using the machine learning stuff. And when moving to the research here, of course, fossil fuel dependency is a major concern here, because as UK, a country which is already developed, using much more fossil fuel under the transformation, under this smart city concept, and my colleagues will explain in the further slides. So the lack of EV incentives. Currently, of course, even some of the EV users, the participants are willing to participate this kind of a proposal. They are currently some of the schemes under these incentives are pretty much lack with the motivation. So that's why this research gap that we are going to present with this presentation. And the grid instability, of course, sometimes with the big demand and the higher demands which is arising because of the unwanted demand of the energy, we are unable to stabilize the grid. So there's another gap we have identified, and also the machine learning underutilization, as we have discussed already. The data analytics, the trustworthiness of the data, and the security of the data can be secure with this application of the machine learning, and need for a scalable model, because of the structured sustainable framework is required to align to financial incentive with this energy stability, because of every aspect of this, the above research gap should be in a proper way to identify our research gap. And from here onwards, so my colleague will continue, as most of the basic concept which has been based on this research, they will explain what are those concepts, as well as how they are going to impact our study and this the research areas, as well as what are the areas that can be developed with the financial, economical, and the environment.
So this model can be used to reduce traffic congestion. So the air-based transport system can be used to improve the mobility of the vehicles and the flow of the vehicles. And the stability and net zero goals can be achieved through these models. By utilizing these models, we can use smart transportation to minimize carbon emission. So using EVs as decentralized energy storage, EVs can be used as mobile batteries to electric vehicles have EVs that can supply energy grid during peak demand times. And the V2G technology, which is vehicle-to-grid technology, it enables bidirectional energy flow, stabilizing grid functions. And also, this can be used to reduce grid strains. So the EVs help balance supply and demand, reduce resilience and on fossil fuel which powers the plants, and enhance renewable energy use. So the EVs store excessive renewable energy which can be released whenever needed. And the financial incentive of EV which this model provides to EV users is that it compensates for supplying energy through their batteries during high demand periods. But there are certain limitations in the current incentive model. There are lacking dynamic pricing. So the fixed electric tariffs do not reflect real-time demand fluctuations, and there are limited financial incentives, such as the existing programs only have they fail to adequately adapt to renewable energy EV users' energy contributions, and the battery degradation concerns. By providing the EV supply, the users hesitate to provide that because this can reduce the use of the battery's lifespan, and there are restrictions in off-peak charging windows, so the fixed off-peak hours may not align with users' needs or the grid demand. So there are low adoption rates due to these reasons, as well as insufficiency of awareness and also the financial motivation and the concerns with the battery, and which concerns altogether concerns the EV participation in energy trading. So the proposed EV income model, the overview of this model is that it provides a dynamic pricing system which adjusts electricity tariffs in real time based on demand and supply, and also it contributes contribution bonuses are that it incentives EV user owners which make them supply stored energy during peak demand times, and also the battery health subsidizes, which provides financial support to offset battery degradation concerns, and the real-time data optimization with the use of AI-driven analytics to forecast energy demands and optimization incentives. We can predict the real-time data demand and supply, and thus scalability and sustainability is also achieved through this model by aligning the financial rewards with the energy efficiency and the demand. It encourages the widespread EV participation. So the predictive analytics using machine learning. So for this model, we use predictive energy demand. Using an AI model, we analyze the historical data to forecast the peak demand periods, and also we use the Bayesian probability for decision making to dynamically adjust the energy distribution based on the real-time EV availability and the grid demand. And also we optimize the EV participation by identifying when and where the EV should be supplied, and in order to maximize the energy use and efficiency. And also through the use of AI, we process the data in a real-time model using machine learning models, and also we enhance the financial incentives through the AI-driven insights to help optimize the pricing and encourage the EV owners' participation. So the smart grid and V2G integration, by using a bidirectional energy flow, this V2G technology allows EVs to supply and draw energy from the grid, and the grid's stability enhancement is also concerned in this. So the EV acts as a decentralized storage unit, reducing peak loads and stresses to the grid. and the optimized energy distribution is also concerned through this model. So the smart grid uses real-time AI analytics, balance supply and demand efficiently, and also it integrates renewable energy through the EV stores. The EVs store the excess solar and wind energy, which can be used for peak demand times and make clean energy more reliable for use. And also there's economic and environmental concern. So the low energy costs and reduced carbon footprints improve the energy efficiency as well as the impact on the environment.
So there are many impacts using this system. So as the economic impacts, it reduces the grid management cost, and EV users collectively clean up 1.2 billion annually by 2015, and also it helps for job creation and market growth, and it lowers the energy cost for consumers, and it increases the environment sustainability and the energy. So when we consider the environmental impact, it always reduces CO2 emission and also less fossil fuel dependencies, and increase the renewable energy utilization and lower the urban air pollutions, and it transits the energy to sustainable energy option. So as the policy and infrastructure development, it implants the policies to support real-time pricing for energy demand management and EV charging infrastructure expansion, and financial support for EV owners, and also it ensures the compliances with GDPR for AI-driven energy management, and it integrates the renewable energy systems. So there are some challenges as well as risks in this adapted system. So there are some adoption barriers and battery degradation concerns, as well as regulations and policy gaps, as well as data and privacy and cybersecurity problems, and also infrastructure and grid stability problems. So as the future research and recommendation option, so it enhances the AI and machine learning models and develop the advanced incentive structure, and also research on extending battery lifespan and improving the energy storage efficiency, and expand the smart charging network to support widespread EV grid integration, and it make a policy and regulatory framework. So here, so we engage. So as the next step, we are getting the help from the industry collaboration and investors and policymakers and researchers and educators to drive through to achieve the sustainable energy solution. So at the end, so EV as a key energy to achieve future action plan, we need to consider these 4 key areas like EV as key energy assist, machine learning for optimization, and financial and environmental benefits, and policy infrastructure development. So by combining these areas, what is we need and what is our ultimate goal is to achieve peak energy demand management system for UK. So this is the end of our presentation. Thank you.